Hey guys, Eric here. Let's talk about bismuthate. So, bismuthate is an ion made up of one atom of bismuth and three atoms of oxygen. It has a charge of -1 and is a very strong oxidizing agent. Now we know the basics of bismuthate. Now let's talk about the chemical bonding of bismuthate. First off, we're gonna start with the total number of shared electrons. So the formula for this is S is equal to N minus A, where S is the total number of electrons shared in the molecule or polyatomic ion, N is the total number of valence shell electrons needed to achieve noble gas configuration, and A is the total number of electrons available in the valence shell of all of the atoms. So for bismuthate, we have a total of 4 atoms that can achieve the octet rule because their valence shells can hold up to 8 atoms. So we put in 8 times 4. Next is A, the total number of electrons available in the valence shell of all the atoms. So first off, let's have bismuthate. So bismuthate is a group 5 element. So the group of an element also describes its outer electrons, or the electrons in the valence shell of the atoms. So bismuthate has 5 electrons in its valence shell. So it has only one atom, so 5 times 1. Then for oxygen, it is a group 6 element. So it has 6 electrons in its valence shell, while it has 3 atoms, so we have 6 times 3. And then, of course, we include the charge of the bismuthate. So bismuthate has a charge of -1. So we put in +1 because it is the charge, total number of electrons available. Now that we both have N and A for the formula, we can now compute the number of shared electrons between the bismuth and the oxygen atoms in bismuthate. Calculating for S, we now have a total of 8 shared electrons, and dividing it by 2 will give us the number of bonds for the bismuthate. So we have 4 bonds. Next up, we will now determine the central atom through electronegativity. So bismuthate, with bismuth, it has 2.02 electronegativity, while oxygen has 3.44 electronegativity. So according to the rules of chemistry, the element with the lower electronegativity will be the central atom. So comparing the electronegativity of bismuth and oxygen, we have bismuth as the central atom. For the Lewis dot structure of bismuthate, we have the number of bonds, which is 4, the central atom, which is bismuth, and the formal charge, which is -1. So first off, we determine the bonds. So since bismuthate has 4 bonds and the central atom is bismuth, we can put bismuth in the middle, then draw 4 lines connecting bismuth and the 3 oxygen atoms. So we have 1 double bond and 2 single bonds. Next up, since oxygen has 8 electrons, it can have 8 electrons in its outer shell. We have to put the remaining number of electrons besides the bonds. So since the double bond oxygen already has 4 electrons, we now add 1, 2, 3, 4 to its outer shell. Then For the other oxygen, it has 2 electrons, so we put 1, 2, 3, 4, 5, 6 electrons. Now, for the formal charge of bismuth, which is -1, we put it outside. So we put a bracket in the Lewis dot structure of bismuthate, then put -1 outside. As for the number of electron groups of bismuthate, we count the bonds. So we have three total bonds, which is a double bond and 2 single bonds. So bismuthate has 3 electron groups, since there is no extra electrons of bismuthate. So there we have 3 electron groups. For the electronic and molecular geometry, we can see that bismuthate is a trigonal planar. So comparing the shape of the trigonal planar with the bismuthate Lewis structure we have created, they look similar. Now for the last part, we have the hybridized orbital. So the hybridized orbital is based on the electron configuration of bismuth. So we have the electronic configuration of bismuth, which is xenon 4f14 5d10 6s2 6p3. Based on its outer shell, the outer shell of bismuthate, I mean, the 6s and 6p are the outer shells. So we now have 5. So now we have 5 charges. So we put 3 in sp2, since 6s2 has 2 charges, and then we take 1 from 6p. So sp2 has 3 charges, while 6p has 2 charges from the remaining charge in 6p. So since hybridized orbital, we are talking about hybridized orbital, so hybridized, which is combination, sp2. So there we have it. That is the bismuthate, the chemical bonding of bismuthate. Thank you for watching the video. So